If you are new to our channel, so today's topic is rectifiers. Now, what are rectifiers? Those electronic devices which convert AC into DC, alternate current into direct current. They are known as rectifiers. Okay. In our daily life, we use the mobile chargers, okay, laptop chargers. So they contain rectifiers, okay, because the electricity which is supplied at our homes, that is purely AC, and the mobile devices, tablets or laptops, they all work on the DC. Okay, so whenever charging is done, the AC is converted into DC with the help of those devices. So I hope it is clear what are rectifiers.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now two types of rectifiers are there. First one is half wave rectifier. Now in half wave rectifier, the basic thing is one step down transformer. In step down transformer, we know the number of coils or number of turns in secondary coil, that is less as compared to number of turns in primary coil. Second thing, we will use one PN diode. Okay. And third one, we will take one load resistance. Now the construction part. Let's say this is a primary coil of a transformer. See, whatever AC which is to be converted into DC, that is fed into primary coil. Okay, let's say the AC voltage here is V equals to V naught sine omega t. Okay,
Sir, here
this
you have
is
written
primary
step.
coil.
Sir,
Yes, beta.
so here you have written step down transform. Are these all examples of half wave rectifier?
No, this is the part of, you can say the parts of the half wave rectifier, step down transformer, PN diode, and load. These three
Yes, sir.
things we use to form a rectifier. Clear?
Yes, sir.
Okay. In, in secondary coil, the number of turns are less, and here we use one PN diode, and there is one load resistance. Across the ends of the load resistance, we will get the output voltage. Okay, let's say output voltage is V naught 1. Okay, now see the working part. We know the AC waveform of voltage. Let's say this is input, and over here input voltage waveform, that is like this. Sinusoidal function we know very well. Okay, this is positive, then negative, then again positive, then negative. So 0 to T by 2, then T, 3T by 2 and 2T. Now, before starting this functioning or working of this half wave rectifier, I would like to ask, when we will say the diode, PN diode is in forward bias? Yes, any one of you?
So when the p-type semiconductor is connected to the higher potential and n-type semiconductor of a PN diode is connected to a lower potential, we can say so.
Okay. So remember that higher and lower potential, P is connected to higher potential, N is connected to lower potential of this PN diode. Then we will say it is in forward bias. Now see carefully, if I talk about this AB, let's say AB are the ends of the secondary coil. Okay. Now whatever AC is fed into the primary coil, due to mutual induction, EMF will be generated in the secondary coil. Right? So let's say at any instant A is at higher potential and the B is at lower potential for the first half cycle. Okay, 0 to T by 2. For the first half cycle, A is at higher potential and B is at lower potential. Now A is connected to P part of the diode and N that is connected to B lower potential. So say now this PN diode that is in forward bias.
Yes, sir.
So what will happen? Current will flow through this diode, resistance, load resistance, and we will get this output voltage V01 as I into RL. So for the first half cycle, we will get the output, and this output is because of the rectification through the diode. This is output, first part. First part is clear to everyone?
Yes, sir.
Yes.
Yes, sir.
Okay. Now if we talk about the next negative half part, okay, for the next negative half part, what is going to be here? See, if I say for the next half from T by 2 to T, okay, from T by 2 to T. Now the A will be at lower potential because now it is negative, voltage is negative. So A will be at lower potential and B will be at higher potential. Now when A is at lower potential and B is at higher potential, it simply indicates that the P part is connected to lower potential and N part is connected to higher potential. Can we say now this PN diode is in reverse bias?
Yes,
Yes,
sir.
sir. Yes, sir.
Because this PN diode is in reverse bias, the small negligible amount of current of order of 10 raised to minus 6 ampere will flow through it. So 10 raised to minus 6 milliampere, 10 raised to minus 6 ampere current that is flowing through load resistance. Almost we will get zero voltage, almost zero, because 10 raised to minus 6 is very small quantity. So output because of this second half 0 to T by 2 to T, that is 0 volt. Is the second part clear to everyone?
Yes, sir.
Yes, sir.
Okay. Now again we talk about time interval T to 3T by 2. Again voltage is positive. So this time, now what will happen? This A is at higher potential and the B will be now at lower potential. Okay. Now this time we can say this PN diode is in forward bias. Now if it is in forward bias, then current will flow through the diode and we will get the output across the ends of the load resistance. Okay, I into RL. So this time again we are going to get the output for T2 3T by 2. Okay. Further again for the next negative half again we will get the 0 voltage because it will be in reverse bias. So now you can see out of one complete wave, okay, 0 to T, that is one wave, we are rectifying only the half part only. Okay, half part is rectified. So that's why the name of rectifier is given as half wave rectifier. I hope it is clear to everyone.
Yes, sir. Yes.
Yes, sir.
Remember that here very important thing is frequency of input voltage and frequency of output voltage. Okay, that is same in case of half wave rectifier. So time period is not changing, so frequency will also not change. Just note down this part, draw the diagrams quickly. Now remember that the full wave rectifier again is formed. First of all, we will have a step down transformer, but instead of saying step down, it is center trap step down transformer. Okay, first one. Second thing is it has two PN diodes. Let's say it is D1 and D2. And third one, it has a load resistance. Okay. Again, we will draw the diagram of this full wave rectifier. Now you can see in the primary coil, we have connected an AC which is to be converted into DC. Okay, this is primary coil, and because it is step down transformer, so number of turns in secondary coils, that is less. Now over here in the secondary coil, two diodes are connected parallel to each other along with a load resistance. Now this load resistance, that is centrally trapped with the transformer. This is load resistance RL. It means whatever output we are getting, the output will be across the ends of this load resistance. Okay, let's say these points are PQ. Okay, I hope construction part is clear to everyone.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, now working part is little bit similar to the half wave rectifier. Focus on the diagram and you will come to know about this easily. Okay, here we start. Let's say this is for input voltage. Zero to T by 2, then T, 3T by 2 and 2T. This is input voltage. Okay. Now First of all, if I talk about the positive half from 0 to T by 2, okay, A will be at higher potential and B will be at lower potential. Okay. Now if I talk about this D1 diode, in D1 diode, the P is connected to positive part means higher potential and N is at lower potential as compared to A. So D1 will be in forward bias. Okay. Now if the D1 is in forward bias, it will conduct electricity and current will flow in clockwise direction, as you can see. Okay, it will be in clockwise direction. So current is here, let's say I1. When this current is passing through the load resistance, we will get output because of D1. So here, with respect to D1 diode, if I want to write the voltage VD1, we will have the voltage, okay, positive. Now with respect to D2, what will happen? Just check it. If I say D2, okay, in D2, this is P part and this is N. P part is connected to lower potential as compared to N. So this will be in reverse bias. D2 that will be in reverse bias. So in reverse bias, will the current flow?
No, sir.
No, sir.
Current will flow, but it will be negligible. Okay, 10 raised to minus 6 ampere. So almost zero output
Yes,
we will
sir.
get. Okay, so zero output we will get because of D2. So here I am making D2 at 0 voltage, right? Now further if I talk about the next time interval T by 2 to T, there is negative voltage. Now negative voltage means now A will be at lower potential,
Lower potential.
right? And B
Yes,
will
sir.
be at higher potential with respect to A. So the first diode D1, P part is connected to lower potential, N part will be at higher potential with respect to A. So this time we can simply say this diode D1 that is in reverse bias. And if it is in reverse bias, it will not conduct electricity. We will get zero output. Okay, we will get zero output. And if we talk about this D2, now P part of D2 is connected to higher potential and N part at lower potential as compared to B. So D2 now it is in forward bias. So when it is forward bias, current will flow right in anti-clockwise direction. But here the direction of current in RL is same. Okay. So again we will get output corresponding to this time interval T upon 2 to T. That is positive output. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now same again for the time interval T to 3T by 2. Because of D1 diode we will have positive output. Okay. And because of D2 we will have zero output. Right. Then next portion again for the time interval 3T by 2 to 2T. For D1 we will get zero output. But for D2 we will get output, positive output plus. So final output I am writing here, final output, okay, it will be because of D1 and D2. Now let's see what will be the output here. We will add all these. So the final output which we are getting, it is like this. The first one is because of D1, then third one is again because of D1, second one is because of D2, fourth one is because of D2. So finally we are having output voltage which is not purely DC nor purely AC. So it is a combination of AC and DC because negative current, negative voltage is not there. Now you can see the complete wave is rectified from 0 to T. So that's why the name is given full wave rectifier. I hope it is clear to everyone.
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Yes. So now in this full wave rectifier, if let's say frequency of input that is F and time period is T, input time period is T, then frequency of output, okay, that will be just double that of input, and time period of output voltage is half that of time period of input voltage. You can see now the repetition is done by half time interval. Is it clear to everyone?
Yes, sir.
Yes, sir.
Okay.
Yes.
So draw this diagram. Okay. Note down each and everything.